In this pod, we'll investigate the suitability of equipment to measure the speed, frequency, and wavelength of a wave in a solid and a fluid.
Before you start this investigation, it would be a good idea to take a look at the wave equation. Wave speed equals frequency multiplied by wavelength. Wave speed is measured in meters per second. Frequency is the number of waves per second and is measured in hertz. Wavelength is measured in meters, and the symbol used is the Greek letter lambda.
You can find the speed, frequency, and wavelength of water using a ripple tank. A ripple tank is a shallow tank of water with an oscillator at one end. The oscillator is connected to a power supply. Ideally, the bottom of the ripple tank should be made from a transparent material so that you can put a sheet of white paper under the tank. This allows you to see the waves more clearly.
To calculate the wavelength, set the distance between the oscillator and the end of the tank to your chosen length, let's say 20 centimeters or 0.2 meters. Then use a camera to take a picture from the top of the tank. Count the number of waves in your chosen length and find the wavelength in meters by dividing the total length by the number of waves.
To calculate the frequency, choose a point on the tank and count how many waves pass in 10 seconds. Then divide this number by 10 to get the frequency in hertz. This could get tricky at higher frequencies, so it would be better to make a short video of the waves. Make sure you have a stop clock in the screenshot. Then you can play the video back at a slower speed, so you can count the waves more easily.
Repeat the experiment by setting the oscillator at different frequencies. Make a note of the results you have obtained in a table. Now you can calculate the wave speed by using the wave equation for each set of results. Remember that wave speed equals frequency multiplied by wavelength.
To investigate the wave speed, wavelength, and frequency of waves in a solid, you'll have to set up something called a standing wave. To do this, you'll need to set up the apparatus as shown in the diagram. The apparatus consists of
a vibrator fed from a power supply, a signal generator, the material being tested, which is a string, a wooden bridge to keep the string horizontal, a pulley, a weight to keep the string in tension, and a meter rule to measure the wavelength. The wavelength should be the same each time, within reasonable accuracy.
Now turn on the vibrator to start vibrations in the string. At this stage, the waves will be moving across the string and will be hard to distinguish. If you turn up the frequency of the vibration, the waves will become easier to see. If you keep increasing the frequency, the wave will appear to stop moving and produce what is known as a standing wave. This is one complete wave.
The length of the wave is measured using the meter rule. The frequency is the frequency of the signal generator. From these two pieces of data, you can calculate the speed of the wave using the wave equation. Wave speed equals frequency multiplied by wavelength.
To continue the experiment, move the bridge to alter the length of the string, reducing the wavelength each time. Now adjust the frequency by altering the signal generator output to produce the standing wave. Again, use the wave equation to calculate the speed. You should get the same wave speed each time within reasonable accuracy.
You can repeat the investigation using different thicknesses of string and different materials. You can also increase the tension of the string you are testing by adding more loads to the tensioning weight.